Okay, welcome back. So in this video, the previous two videos, we had a look at trigonometric graphs, how to sketch them, and some of the questions you can expect about them. And now I want to look at some of the 2D problems you can expect regarding trigonometry. Okay, so looking at this question 5, they say, the diagram below shows a spotlight at point B, mounted 12 meters directly above point C. The spotlight swings 44.3 degrees to another point D, and when they say AC is the midpoint. Alright, so when they mention that something is the midpoint, it means that the distance from the one side of a line and the distance from the other side of a line is equal. Alright, they also did indicate it to us, and now they ask us in the first question, calculate the length of DC. Now, before we usually start with these questions, the easiest thing to do is go and see how many 90-degree triangles do I have. Alright, so looking at this specific sketch, I can see I have one 90-degree triangle here, triangle BCD, which I made in green. But then I can see I also have another 90-degree triangle, which is my bigger triangle, which runs from A, B, and C. Alright, so if I had to redraw it, I would draw my one triangle here. Alright, so this will be triangle BAC, and in this one I have angle there, which I know is theta plus 44.3 degrees, and I know that BC is 12 meters. Alright, then I also have my green triangle, which is my smaller triangle. So let's quickly draw that one here. Alright, so the reason why I break this up is because sometimes our brain struggles to calculate things if it looks too big. Hence the reason why I'm breaking it up. Alright, and then my green triangle, I have angle B, D, and C. And I know that BC is 12 meters. And I know that angle here at B is 44.3 degrees. Alright, so usually if you don't know what to do, always start with your common side. So in this case, we have two common sides. Alright, we have this part here at DC, which is common because they're in both triangles, and we also have BC. Okay, but now that we know this, we broke it down a bit, let's start answering the questions. So in question 5.1.1, they say, calculate the length of DC. So in which triangle is DC? Is it in my big blue triangle or my small green triangle? Alright, so I can see that DC is in my small green triangle. There it is. Alright, so we're not going to use the blue one at the moment. We're only going to focus on the green one. Now remember, with these things, if you have to calculate a side, you're always going to be given one side and an angle, or you're going to be given two sides, and then you can work out the third side using Pythagoras. So let's see what we have here. They gave us our angle as 44.3 degrees. Then they also gave me line BC, which is 12 meters. And now using my angle, I can see, wait, it is touching my angle, so it is my adjacent side. Of vir Afrikaans learners listening, it is my aangrensende side. And then the side I want is opposite my angle. Okay, dit is teenoor my hoek. So DC will be my opposite side, of in Afrikaans my teenoorstaande sy. Alright, so having this information, I'm going to ask myself, which function has an adjacent and opposite? Watse funksie is aangrensend en teenoorstaand? And then I know adjacent and opposite has to be tan. So tan theta is equals to my opposite over my adjacent, my teenoorstaand teenoor my aangrensend. So now I can just substitute. So I said that my angle is 44.3, so it's going to be tan 44.3 degrees is equal to my opposite side, which is DC, over my adjacent side, which is 12. And now here is DC. DC is at the top, so I'm leaving it there. I'm only taking over my 12. And if I'm taking it over, it's going to multiply. So I basically have that DC is equal to tan of 44,3 degrees. Multiply that with 12. And that gives me that DC is equal, let me just quickly put this into my calculator. Okay, it gives me that DC is equal to 11,71 meters. Alright, so there we have the length of DC. So before you go to your next question, go and fill in the information. So I know that DC is no longer a question mark, it is now 11,71 meters, and I'm going to put it here as well, so I know that. What I also know now is what they said here, that AD is equal to DC, which means that AD will also be 11,71 meters. Alright, so now we can go to question 5.1.2, where they say, calculate through how many more degrees the spotlight must be swung in order to illuminate point A. Therefore, calculate theta. Alright, so theta is here, and that is part of my big triangle. Why is it part of my big triangle? Right, because it's part of my blue triangle. It's my entire angle B. Now, looking at my blue triangle, I already have the length of AC. I know it's going to be 11.71 plus 11.71, or you can multiply it by 2, and that gives me the length of AC as 23,42 meters. Alright, so now we're moving on to question 5.1.2, but now I'm going to use my blue A triangle. Okay, so I want to calculate the angle, and the angle I want to calculate is angle B, or theta. Then I also have two sides. I have BC, which is 12 meters, which is my adjacent side. Dis my aangrensende side. But then I also have the side opposite my angle. So I have my teenoorstaande side ook. Okay, so I have my opposite side, which is 23,42 meters. Now I'm asking myself a question again. Which function is adjacent and opposite? So I know that that is tan. So tan theta will be equal to my opposite over my adjacent. Of in Afrikaans, die teenoorstaand teenoor die aangrensend. Calculate, so it's going to be tan theta, or in this case tan B. It's going to be my opposite, which is 23,42 over my adjacent of 12. Now I want to calculate for beta, right, which means I have to get beta alone. So I have to take over my tan, and remember, when I take tan over, it becomes the opposite. So that means if I put it into my calculator, it's now going to be shift tan, or tan -1. Alright, so it's going to be shift tan, and if you put shift tan into your calculator, it's going to give you this -1 automatically, and then in the bracket, you're going to put what we had there. Alright, so that gives me angle B as equal to 62,87 degrees. Okay, but we only want to know theta. So remember, the entire angle B was theta plus 44,3. So now if I only want theta, I'm going to say 62,87 minus my 44,3 degrees. Alright, which tells me that theta is then 18,57 degrees. Right, and this is the answer for question 5.1.2. So what is important to know when it comes to these triangles is you need to be able to break down your triangles. So always go and see how many 90-degree triangles I have, and if you have to, redraw them so that you can see in which triangle lies what we are asking. then you need to know your ratios. You need to know that tan theta is your opposite over your adjacent. You need to know that cos theta is your adjacent over your hypotenuse, and that sine theta is your opposite over your hypotenuse. That you need to know, and then you also need to know how to work with equations. So if you're dividing, you know the opposite is multiplication. If I take over my identity, so my sine, my cos or tan, it becomes shift sine, shift cos or shift tan, etc. Right, I'll be making a few more videos similar to this, but definitely go and revise this example, do it on your own time and see if you can do it. If not, you know you still have to study this, go look at more examples, go back to your textbook, back to your classwork, and go watch for other videos I've uploaded regarding this.